Alright, welcome to this next video. Today we're going to be talking about symmetry and linear isometries, which is just a really complicated way of saying things, and you probably think I'm really annoying for it, but please forgive me. I like complicated words sometimes. So our learning goal is that students are able to represent transformations in the Cartesian plane. And at the end of this, you want to be able to represent a figure on the Cartesian plane and perform isometric transformations on a given figure inside a Cartesian plane. Alright, so this is starting to sort of have a look at this area of mathematics called linear algebra, which is the backbone of computer graphics. Now, if we look at what linear algebra kind of is, x and y, if I had this shape here, like a triangle, I could apply some kind of operation to it, maybe some kind of transformation matrix, let's call it matrix A, and it is equal to, I don't know, let's just make it 7, 2, 3, 5 or something like that. And so I apply this matrix onto our triangle and it's able to move down to here, rotate and become a square. Okay, so linear algebra is sets of operations you can do on all the points inside this triangle to make them become all the points inside that square. Okay, now that you can see that kind of thing happening all the time on a computer when one shape becomes another. If you're playing a 3D game, the way that shapes can kind of transform and change, even as like a human form's kind of moving on the screen or something, all of that is linear algebra. They're not just moving randomly, they're moving according to a set of transformations that are being applied to those shapes as in real time, you know, if you've got good graphics card and stuff. And so this is really starting to look at the basics of those kinds of areas. All right. So basically linear algebra is mapping one set of points to another set of points, really. All right, so let's have key ideas. So there are many different types of symmetries, but we are only concerned with two types. So the first one is reflection symmetry. So an object has reflection symmetry if we can draw a line through it which would produce two mirror images. So with our square here, we can draw this first line down here, okay, and that produces a mirror image, but we can also go across this way and do it as well. Okay, so if you count all the different types of reflection symmetry, our square has 1, 2, 3 different, 1, 2, 3, 4 orders of reflection symmetry. Okay, this star here has 4 as well. This cross has one going this way and another going this way, so it only has 2 orders of reflection symmetry. Okay, so that's our first way of looking at symmetry. Our next one, and that's called an axis of symmetry, those different lines there. Now, our next one is rotational symmetry. So an object has rotational symmetry if it looks the same after a certain amount of rotation. Okay, so you can see that this is from the flag of the Isle of Man, but if we got this point here and rotated it round to here, if we rotated this figure around to there, it would look exactly the same. Okay, so and it could be rotated around 1, 2, 3 times before it comes around to being the start again. And so it's got rotational, 3 orders of rotational symmetry. Okay, so and you can rotate it by 120 degrees to go to its next sort of point. All right. So for example, a square, pretend this is a good square, also has rotational symmetry because this point can be rotated around 90 degrees. And when you put the shape back down again, it looks exactly the same. Okay, so that's what rotational symmetry means. Now there's this awesome palace in Spain called the Alhambra, and it has beautiful examples of symmetry demonstrated in these tiled mosaics. It's absolutely wonderful. And in fact, all of those are different things called, shows amazing examples of these things called the wallpaper groups. Okay, which is the different ways that you can tile a plane by performing different transformations and symmetries. Okay, which is really, really, really cool stuff. Okay, all right. Let's have a look now at these things called linear isometries. It's a transformation of points or an object which, this is the important part, preserves the original dimensions. Nothing about the shape, size and stuff is allowed to change. So the first transformation we're going to talk about is a translation. It's just where a figure is moved to change its position, okay? So this shape has been moved to become here, okay? It's been moved 5 units this to the right, then 2 units up, okay? Now you'll notice that A became A prime, which is to say that this is the second version of the point A after the transformation has been applied. All right, so these are just little ways of referring to things, so we all know what we're talking about. Okay, a reflection transformation is one that creates a mirror image of a figure across a line of reflection. So here's our line or axis of reflection. Okay, so pre-image in our image, so we've got an A in our A prime again. So you can see that the distance from A to the line of reflection is the same as the distance from A prime to the line of reflection, and it's at right angles and stuff as well. Okay, right, a rotation creates a rotated image about a point of rotation. So if here's our point of rotation here, we've got A, and it's been rotated around 90 degrees to become a, it's been rotated the other way. A has been rotated around to become A prime, okay? All right, let's have a look at some worked examples. So let's describe the transformation that's shown. So we start with A and we figure out how do we get to become A prime. So we're going 1, 2, 3, 4, 5 units this way and 1 unit up. So therefore, 5 units right and 1 unit up. Okay, funnily enough, you could do this transformation being A is equal to the vector 5, 1. Okay, and that would transform this triangle to become that triangle. All right. Reflect the given figure across the line of reflection. Okay, so remember, let's call this A and B and C. So A prime needs to be exactly the same distance away from the line of reflection and at a right angle. So it's got down to the line of reflection at a right angle and across one more. So there's A prime. So the next B is 1, 2, 3, 4, 5 away. So 1, 2, 3, 4, 5. There's B prime. C is 6 away. So 1, 2, 3, 4, 5, 6. C, not C minus, C prime. And so there's our new shape. It's being reflected across the axis like that. Okay, so there's our reflected figure. Now, you're probably noticing that a lot of this is probably going to take some kinds of graph paper and stuff. So if you don't have any of that to bring, it might be a good idea. Otherwise, we'll be bringing plenty along to class. All right, this one's a bit more complicated. So rotate the given figure 180 degrees about Q, which is this point of rotation here. Right, so the way that we do that is that we draw a line from, so let's go A, B, and C. We draw a line from A to Q, through Q. Okay. A to Q, and then we need to get this line and rotate it around 180 degrees. Okay, which is luckily just a straight line. So if we keep drawing our line through here, is where A prime is going to be. All right, B, B comes across, goes through Q, and comes out here. So same distance away from Q, 180 degrees rotated, and so that is B prime. Okay. And then lastly, C prime, so it comes up through here, then through to here, I think, is where we got. That looks good. So that's C prime, and there's our shape. You might want to use protractors for these, especially if the rotations aren't as simple as 180 degrees, and my drawing is going terribly, but there's my new shape there, A prime, B prime, C prime. Okay, so that's how we do our rotation around different points. So thank you so much for watching. I know a lot of this is probably very busy work, and if you tried to copy it down, well done. Otherwise, you get plenty of chance to practice this kind of stuff in class. And again, practice, 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 especially with the drawing and stuff, because that's a big limitation with a lot of students, and it'll be something that is a great chance for you to get on top of that sort of stuff. Okay, thank you so much for watching.